Okay, so let's assume this teeny-weeny grain of sand, just about 0.1 inches in diameter, is our home planet, Earth. Trust me, we're not even that big on a cosmic scale, so I'm flattering us a lot, you'll see. Anyway, the moon will be just about here, a little over 2 inches away, and we'll have to find a grain of sand that's 3 times smaller than the first one. It's hard to say if this is the one, so let's again assume it is. Now, what's the closest neighbor to Earth apart from the moon? That's right, Venus. It's called our sister planet because it's roughly the same size and mass. So this here grain of sand is gonna be it. As for the distance, we'll have to take a little walk now. And there we go, over 20 feet away from the grain that is the Earth. And that's at its closest, mind you. Next comes Mercury, and it's more than twice as small as the Earth. So let's take a grain of salt this time for variety. How far do you think it is from its neighbor Venus? Not even close. It's here, almost 26 feet away. If you've ever seen a London double-decker bus, it's just short of that vehicle's length. Okay, Mercury is the closest planet to the Sun, so naturally, here goes. The big and mighty star, measuring as huge as this rock. It's roughly 8 inches in diameter, so it fits. Now, where should I place it? Well, you'd better take another double-decker and then some because the Sun's distance from Mercury is 30 feet, even further than Venus. And a walk from here to Earth is quite a trip already. All in all, the distance is just short of that between 2 baseball bases. Cool, huh? But we've only just begun. Moving away from the Sun, next comes Mars, which is twice as small as the Earth. Let it be a red pepper grain this time. The distance to it, though, is even greater than from Mercury to the Sun, over 33 feet, so we'll place it here. And now prepare for the real thing. We're crossing the asteroid belt to reach Jupiter. To do that, we'll need to travel about 275 feet. That's almost the height of the Statue of Liberty. And the planet itself is about the size of this grape, just shy of 1 inch. Now let's take a smaller grape and fly another 330 feet. That's how far Saturn is from Jupiter. Can you still see our rock, sun, from here? I don't think I can. Now, if you take the Golden Gate Bridge in California and decide to rise from its lowest to highest point, that would be the distance from Saturn to Uranus, the 7th planet in the solar system. Notice how distances grow larger every time? That's far from over though. Meet Neptune, Uranus's brother planet. Although they're neighbors, it'll take us another 820 feet to get to it. Put 5 Olympic-sized pools in a line and you'll get the scale. The former Planet 9, Pluto, is our next destination. If we go straight from the Sun, it'll be yet another 4 Olympic pools away, and the size of it is only a speck of ground pepper. Pluto is 6 times smaller than the Earth. And now comes the barely imaginable. Let's first go back to our Sun and start the journey from there. Remember how far that is? Right, more than a half a mile away now. To get to the inner boundary of the solar system from this point, we'll have to travel around the whole planet 4 times. Yep, we're still on the scale where the Sun is just an 8-inch rock. And when it's done, we'll find ourselves in a humongous belt of floating chunks of ice, the Oort cloud. The width of this belt is way beyond our planet's limits, but we'll try. Let's take 3 rocks of the same size as our Sun here and lay them in a line. And now imagine each of these rocks is the size of the real Sun. That's the width of the Oort cloud for you, which goes in a circle around the whole solar system. If we put it to our initial scale, the Sun won't be even visible, no bigger than an atom. So let's scrap it now and start over, shall we? Okay, now this ring of stones contains within it the unfathomable volume of space. Its radius is roughly 1 light year, or 0.4 inches now, and that would be our ground zero for all the following discoveries. The closest star system from here is Alpha Centauri, and it will be about 1.5 inches away. It consists of 3 stars and at least 1 planet that could be inhabitable. The system is too small to see on this scale, but we'll pretend this grain of sand is adequate and proceed further. Next, we go to the edge of the Milky Way galaxy, our home. The galaxy itself is about 100,000 light years across, but we're not far from its very center, so the journey will only take us 50,000 light years. On the super shrunken scale we've created here, it'll be 1,650 feet. If you lay down the CN Tower in Toronto, it'll only be a few dozen feet longer. From here, the nearest galaxy to us is the Andromeda Milky Way. In some distant future, it'll collide with the Milky Way, but right now, to get there, we'll need to travel nearly 15 miles. That's 2.5 million light years in normal count. If you're interested, it's also 2.5 depths of the deepest point in the Mariana Trench, known as the Challenger Deep. Next up is an object we could finally place on a larger scale, NGC 604, a star nebula located in the Triangulum Galaxy. If it were in a single line, we'd only need to travel 1.2 miles from where we are now, so let's do it. And the nebula itself is about 1,500 light years in diameter, which is equivalent to 50 feet. That's like a 5-story building. But let's get back about half a mile and look at something else. This object is almost exactly the size of a Boeing 747, and surprisingly, it's a galaxy, a dwarf galaxy to be precise. Messier 32 is 6,500 light years across and is a satellite to the Andromeda Galaxy. They move together, Messier being tugged along by the gravity of its big sister. And now I'm going to take you for a ride of your life. Get ready. We're going into distances and sizes that would seem impossible if they weren't true. Let's first get back to the circle of rocks that is our solar system. Moving up and away from our star system, we can see the Milky Way galaxy, spanning 0.6 miles wide. Shooting upwards still, we see the great emptiness around the galaxy that we've already crossed today, 15 miles of nothingness. Then we see the galaxies and dwarf galaxies surrounding ours. First the Andromeda, then others, until we're high enough to see the whole local group. It's a galactic cluster in which the Milky Way is no more than 1%. The diameter is 62 miles. But higher still we rise, and now we're looking at a bright and shiny Laniakea supercluster, which is home to the local group. From here, our galaxy isn't even visible. The diameter of the supercluster is about 3,200 miles. It's more than the distance from Los Angeles to New York. And even that's not all. Higher and higher, until we see the Boss Great Wall. It's a supercluster located unimaginably far from us. And on our current scale, its diameter is about 6,200 miles. That's longer than the Great Wall of China with all its branches. No wonder it's the boss. And finally, we're up in outer space now. Even though the model of our whole galaxy stayed so far below, you can't see it without a telescope. And we're now looking at the largest object in the observable universe, the Hercules Corona Borealis Great Wall. On the current scale, it's as far as 62,100 miles away from Earth, or a quarter of the distance to the Moon. And its diameter is the same, so it takes up another quarter of the way. There are trillions upon trillions of galaxies, nebulas, and stars, and nearly infinite possibilities out there. And yet, the universe is always expanding, so it's also only the beginning. Imagine a still frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peak structure, or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation, battering the satellite's surface, which, in turn, increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years, and then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true, and they were amazed to find out that bacteria could easily survive in such conditions for 280 million years, which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium, due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus? Totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed, and it had to make scientists suspicious. But they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere, or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth. Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the 7th planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the 3rd largest planet in our solar system, with a diameter of about 49,889 kilometers. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought that this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet, but if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the positions of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus. And yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yep, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it was so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to 201 degrees. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 579 kilometers per hour. So, you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. And all in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience. And definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover. It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? See, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hansen, 1996, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam! Everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past, and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter Theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth. so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further. 431 light years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets, and then suddenly you see nothing. At first, you're horrified. Has something gone wrong and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can see nothing. The void is a roughly spherical region about 330 million light years across. Our home Milky Way galaxy could fit there billions of times over. And then it dawns on you. What you're looking at is the mysterious Bode's void. It lies about 700 million light years away from Earth in the constellation of Botas, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later it was given its current name. Now we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light years wide. The Bode's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light years. And the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 250,000 HRC. It means it was formed from a gargantuan star, likely more than 5 times the size of our sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face, hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects. And the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light years away in all directions. As for the Eskimo's face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. The deep space colorful object more than 2,000 light-years away from Earth is actually a ring that wraps around a blue, ball-shaped structure. Each end of this structure sticks out of the ring's opposite sides. Now, you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, at Susseyi, it's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DGSat I was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true the galaxy is a real living fossil, the next stop on your space sightseeing tour is the Black Widow pulsar. Just like its spider namesake, this rotating neutron star, J1311 3SFAR 3, is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing, a cloud of water floating in space. To be more precise, It's a cloud of water vapor surrounding a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself.